Okay, we're going to start again. So thank you for those that have come back after this break. I'm sure a number will come in during the talk. But what I'd like to do is introduce Jenny Steinlet and Marta Kuzma. I hope I did that justice, from Micronclean. So their presentation to speak to us today is performance evaluation of cleanroom fabrics over time, subjected to both irradiation and autoclave sterilization. So an interesting topic for many. And I give you the floor and welcome.
Thank you.
Over to you both.
Hi everyone, really nice to see you in person and some friendly faces. So welcome to Micronclean's presentation on performance evaluation of cleanroom fabrics. As a leading provider of reusable cleanroom garments, Micronclean will be reporting the results of an in-depth study which looks at the performance of a range of current cleanroom garment fabrics within the industry. So just to introduce ourselves, my name is Jenny Steinlet. I'm the Cleanroom Sales Manager for the UK. I manage 8 business development managers nationwide. And my colleague, Marta Kuzma, is the Product Development Manager who heads up our product development team. And between us, we've worked in the industry for over 10 years. At Micronclean, our passion is to be the first to develop new technological solutions that change the shapes of the markets that we serve, creating quality and efficiency for our customers. So Micronclean lead the way in the UK for cleanroom contamination control. We deliver quality and efficiency to our customers across the UK. As leaders in the cleanroom laundry industry, this allows us to promote supporting services such as medical devices, cleanroom consumables, and cleanroom cleaning. So as India is the fastest growing pharmaceutical production in the world, our Grade B facility in Bangalore was commissioned in 2020, and it's the only dedicated cleanroom laundry in India. We've recently signed 2 new contracts there to support the COVID vaccine production, Covaxin and Sputnik. So Micronclean has a focus on quality and a dedicated in-house R&D team with a lab allowing continual research and improvement for our products and services. Micronclean have 2 cleanroom laundry facilities based in Lincolnshire. They have an accredited ISO 4 and ISO 6. Our ISO 6 production plant based in Louth is the largest automated facility in the UK. So our strategic ambition is to build a Skegness campus, which is where our head office is based, which would include a new ISO 4 cleanroom laundry. We're currently negotiating to buy the land. We commissioned our first ISO 5 facility in 2018, which is dedicated to medical devices. And by 2027, cleanroom consumables will actually make up 60% of our business. So we're going to give you a bit of a background of the testing, why we've actually done this study. Micronclean have actually invested financially very heavily and dedicated over 2 years' work into making sure that our customers have qualified information. Our research and development team have explored the life cycle of garments in use and the durability of cleanroom fabrics that we use. So Annex 1 requires end users to qualify the replacement frequency of reusable garments. So there are 2 points to this. The selection of the correct garment manufacturer and what the garment experiences in its service. So I'm going to hand over now to Marta, representing our R&D team, to talk to you and explain the study and our results.
Hello everyone, my name is Marta and I will take you through the key points of the study we conducted at Micronclean now. To give you a bit of a background, we've tested 4 cleanroom fabrics. One of them was WF5505JG, which is actually being used by Micronclean. The other 3 fabrics are available throughout the cleanroom industry. We decided to wash up to 100 times, dry and sterilize as well, and we tested the garments at different points throughout that process. And just to clarify, one wash, dry and sterilization is one process in this study. We've covered 2 different sterilization methods, so it's irradiation and autoclaving. There are a few points to make with regards to this data. Results are comparative. So it's a relative fabric to fabric study. Applying these results to any other fabrics that are not included would be very, very difficult. And we had no wearer trials. So this was purely a wash, dry, and sterilization study. Introducing wearers would introduce a level of variation into the test results, because you have to consider different users, different environments, and different activity. And that would make it very hard to then compare the data. So we decided to standardize that and only go with the lab tests. And the testing is destructive. So each data point is a different garment. That, again, will introduce some level of variation in the test results. I will show you now the full scale of the testing that we've done and talk you through all the testing that we have actually conducted briefly. So this table represents all the testing that were included in the study. We will start with particle filtration efficiency, which measures how well cleanroom fabric contain particulate contamination. The higher is the PFE, the better the fabric contains contamination. We've tested tensile strength, which measured the force required to break the fabric. That's related to wear and tear of the garments. The greater the force fabric can withstand, the better the performance of the fabric. Abrasion resistance is another test which relates to wear and tear of the fabric. It measures the fabric durability to rubbing and scuffing. And again, the more of those the fabric can withstand, the better the performance of the fabric. The next test we've done is the pore size, which measures the fabric ability to contain particulates released by the wearers. And here, the smaller the pore sizes, the more likely the fabric is to contain that contamination. However, this could mean the fabric isn't as comfortable to wear because it's not going to be as breathable as maybe some other fabrics. Air permeability relates directly to the wearer comfort because it measures how freely air can move through the fabric. So the higher the air permeability, the more comfortable fabric will be to the wearer. We will now go through some of the test results in a bit more detail. So we will start with particle filtration efficiency, which I will call PFE, just to shorten it a little bit. This study was conducted by an external lab, and all the other tests that we are presenting were conducted by external labs as well. It requires a known quantity of particulate to be released on one side of the fabric. Then there is a suction applied, which is pulling those particulates through the fabric. And then the percentage of particulates filtered is measured to give you the result. This table presents all 4 fabrics that were tested. What you will see very clearly is that Micronclean's fabric has the highest initial PFE result at the beginning of the study, and it had a very marginal drop, only 2%, throughout the whole study. The other 3 fabrics either had lower PFE to begin with, or they may have had quite a big drop at the end of the study. And if you look at fabric D, that had a significant drop, that was 15%. So this was irradiation. Now we will go over to autoclave. What you will see here that there are only 3 lines, and that's related to the results I showed you before. Fabric D was introduced a little bit later into the study, and our results were not very good for irradiation, so we decided to exclude that fabric completely from the autoclave study. So we've got 3 fabrics here. What you will see here, that the blue line representing Micronclean's fabric has the best performance throughout the majority of the lifetime of the autoclave process. And to summarize the PFE results, most fabric maintained good performance throughout the whole study, apart from fabric D, which had a very big drop. And good performance when new does not guarantee good performance throughout the use, throughout the lifetime of the fabric. And PFE is comparable when fabric is radiated and autoclaved. So we will move on to tensile strength, where a piece of fabric is gripped in the jaws of a tensometer, and an increasing tensile strength, tensile force is applied until the point at which the fabric breaks. Again, we are starting with irradiation results. You will see two sets of graphs. That's because we were testing warp and weft. One of them is testing a fabric horizontally, the other one vertically. So what you will see clearly on this graph, fabric D again had not very good performance. The drop was quite significant after about 50-60 processes. The green line representing fabric C is performing pretty well. And the most consistent throughout the lifetime or throughout the whole study was Micronclean fabric and fabric B with the most linear drop, which is quite good. Now moving on to the autoclave. Here again you can see that the lines are kind of closer together, but you will again see that the blue line, which is representing Micronclean's fabric, had probably the best performance. It starts quite well with the rest of the fabrics, but the end result after 100 processes is actually the highest. And this graph represents the average results of irradiation and autoclave, just to compare the two methods. This is quite interesting. We will see that for the first 60 processes, irradiation is giving better results. But for the remaining 40, autoclave would suggest, autoclave would actually be giving better performance. So it really will depend what you're after when you're looking for a fabric, what you want to choose. Again, just to summarize, tensile strength, it varies over time by fabric, particularly around 50-70 processes. And it's, as you've seen on the graphs, the autoclave fabrics have a better tensile strength at the end of the study, which is around 100 processes. Irradiated fabrics maintain their tensile strength better from about 0 to 50-60 processes. So we are moving on to abrasion resistance, which involves moving a sample of a fabric over a standardized abrasive surface in an oscillating pattern and counting the number of cycles the fabric can withstand. We are again starting with irradiation results. You will see that fabric C and Micronclean's fabric have the best performance, but what you will also see that they start dropping quite significantly from about 50. However, that drop is not as significant as the other two fabrics, because you can see that they start dropping before 50 really, and that drop is quite significant. And that drop relates really to wear and tear of the garments. The autoclave data is a little bit more linear for most of the fabrics. However, you will see again, fabric B is not doing too well. Micronclean's fabric again is looking like it had the best performance throughout the entire lifetime. There is a slight dip, sort of between 50-70 processes, but it's not as significant as some of the other fabrics. And it maintains pretty good performance throughout the whole study. And again, looking at the average results for sterilization, so two different types, you will see very clearly from this graph that there is a drop in performance after a number of cycles for both sterilization methods. For irradiation, it starts a lot sooner, and that drop is quite significant. When you look at the blue line, which is autoclave data, you will see the graph is a little bit more steady. It's a bit more linear, so that drop-off is not as significant as the irradiation. Again, to summarize this set of data, Autoclaving is generally preferred for abrasion resistance, and you can see sharp decline at high process counts on the irradiated fabric. And individual fabrics, can see some variation in mid to end life, but they are ultimately degrading quite evenly. And I will just summarize what I've been talking about for the last few minutes. Not all fabrics have the same performance over the lifetime, and you've seen a few graphs showing that some fabrics can start really well at the beginning of the study, but they drop with their performance, some of them quite quickly, some of them a little bit later in the study. So the point I've made earlier, the good performance at the beginning doesn't mean good performance at the end. Autoclaving and irradiating are largely comparable when you look at all three set of data that I showed you. And just to kind of make it clear, the data I presented you today is not the full data of the study. We've selected the more informative data to present to you today. However, we have submitted a peer review paper to European Journal of Parental and Pharmaceutical Sciences. So we are hoping that this will be published soon. If you are interested to see the rest of the data in a little bit more detail, please keep your eye out on that. I'm hoping this will be published quite soon. Just wanted to thank you for listening, and I will now hand over to Jenny, who will try to explain what this means in reality.
Thank you, Marta. So what does this mean in practice? The reality of this study, when your units are audited by the MHRA or governing body, do you know and can you prove the garments are fit for purpose? Do they uphold the required guidelines? If not, then you could be open to a non-conformity. So Annex 1 requires end users to qualify the replacement frequency of reusable garments. As a supplier, we can now provide a comprehensive validation guide to give you and your auditing body the required data that's requested. This data will allow you to make a confident and informed decision on the choices you make for your cleanroom fabrics. So that concludes our presentation today. So thank you, everyone. We're happy to take any questions now, or you can come and find us on our stand in the exhibition hall. Thank you.
Thank you both very much. Another interesting topic. I see the room filled up whilst I have my back to you. Are there any questions from the floor? None have come in online yet. Could you just introduce who you are? And
Sorry, I'm Henry from Advent Bioservices. I'm just wondering, with your tensile strength testing, were you looking at like the main body, or were you focusing more on the seams to see where the seams are probably going to have more of an issue with separating? So when you're just looking to see how it affected, how radiation and autoclaving affected tensile strength, was it where were the samples taken from?
So just before that, just for the online crowd who are watching, so the question from Advent Bioservices was relating to the tensile strength testing and what part of the gown fabric was tested. Was it body or seam related?
So I think the testing was done in triplicates. So the samples would have been taken from different areas of the fabric. To give you a very specific answer, I have to look at the test method that was used by the lab. So I can check that specifically, but I believe we would be looking at different areas of the garment, because there will be samples taken, cut out from the actual garment, and then tested.
And then the last question.
Of course.
With the fabrics, the anonymized ones, were they competitors or were they alternatives that you were looking into or deciding which fabric you were going to be using?
So just to repeat, the question for the larger audience is for B, C, and D, which were the alternative graphs that you'll have seen on all of the data sets. Were they other Micronclean products or past products or other experiments, or were they competitor garments?
They are fabrics within the cleanroom industry of our competitors, yeah.
David from Cambridge Pharma. Some of your results do go up and down.
Yes, yes.
Any explanation for why sometimes they get better with age?
So the question was, why do we get better? Why do the garments get better with
Why do
age?
the garments get better?
Right, okay,
We
so
also get
some
better
of
with age,
the data sets were moving up and down across their life cycle, as we all do. But yeah, is there any explanation to the trend?
It's experimental variation. So some of these results, the dips especially, they were discarded really. It just happens when you test that you will have some variation. I've mentioned on a couple of occasions that there are a few factors that make those results a little bit varied. Every garment is a different, every testing point is a different garment. That in its own right would introduce that level of variation. So yeah, it is just that kind of thing. We are discarding a lot of those funny results actually from the testing because we know this is expected basically. But there is no scientific answer to that really.
A question from our virtual audience. Was there any information on particulates from the garments over the life cycle? So I think that relates to their containment. So you've talked about performance of the product and its life through cleaning processes, through irradiation or sterilization processes, irradiation and sterilization. But was there any particulate data that you would like to speak to? I think you did present.
Yeah, so
yes.
we've presented the summary of the PFD
yes.
throughout. There will probably a bit more data in the peer review paper, so I would recommend looking at that paper when it's published. Can't really say too much more before.
Yeah, no, I remember seeing
published.
a graph, but maybe
Yeah.
that was missed at that time. But PFE, maybe that was an acronym that wasn't.
It was, yeah. So that data, full data, will be actually available in the peer review paper. Yeah. I only presented you with the summary of the data because I couldn't go through all the details. Believe me, there was a lot of data.
Be here for hours.
We'll be here for hours, actually.
So to the virtual audience, yes, it was. Look for that peer review data in the EJPPS, which hopefully we'll see published in the near future.
Yeah, thank you.
Okay.
Amy from Merck. Based on customer feedback, did you go into the study expecting any variation between autoclave versus irradiation process?
So the question was, did you go into the study expecting to see a deviation between the two sterilization processes of irradiation or sterilization?
Yes, we definitely did. We know from our knowledge within the industry that there would be a difference. We actually use autoclaving in our facility in India, and we use gamma irradiation in the UK. So we have to consider both in the studies, and yes, we completely understand that there would be a difference. It was actually interesting for us so that we can consider the future of sterilisation. As we know, there is a shortage of cobalt worldwide, so we really wanted to include the results for autoclaving and have a good comparison for the future.
Yeah, thank you for your question. There was another one at the back.
When you did, I'm most focusing on mechanical testing, but did you have any? You said that you weren't using people who were wearing the gowns to try and make it a bit more of a controlled experiment, but did you have any comparisons to what would be expected in the real life? So what kind of forces you would expect someone to be putting onto the gowns in a lab, just so we have a reference point, because one reference point of what is realistic and acceptable level of force to be, what is an acceptable level, what forces should you be expecting on a day-to-day level on the gowns? And
I can repeat that bit very easily. So the question is, what forces would a normal person in a clean room environment exert on the gown fabric, and was that representative in what you applied through the study?
It's extremely difficult to say what is typical of garment in use. It would be very there's so many different variations of how people use their cleanroom garments. Some are much more active than others. So it wouldn't really be easy to kind of decide the stress levels that those garments are being put through, because each individual customer would be completely different. So no, that's why we didn't choose to use wearers within this study. But if it is of interest, then what we would do as kind of experts in that field is have a look individually at customers and understand that, so that we could make the right recommendations depending on the use of those garments.
And just to add, the testing labs that we've used, they're all accredited to 17025. They have standardized test methods. And as I was saying earlier, it is a relative study of fabric to fabric. So they would have used a standard force on the tensile strength testing. But what that obviously allows you is to compare fabric by fabric with the same conditions, if you like, applied in the lab. So it is a comparative study.
Thank you. One right at the back.
Sorry, Anthony from Cytiva. I guess the question I got in my head is, where's the failure point? So why 100 cycles? At what point is the gown not fit for purpose as it's gone through multiple wash cycles?
So the question relates to your study went to 100 cycles, but what is the life cycle expectation of a gown or the gown or those fabrics in our real world situations?
So why 100? Like we actually tested these garments, and I think we've been making decision on the go how much more we want to push them and can push them, but based on the results that we were getting. If we were seeing a drastic drop in the performance, like half of the performance is gone, we wouldn't probably carry on the results, because it wouldn't really make much sense. But because some of those results were still quite good, we decided to carry on to 100. But where is the failure point? It's a very good question, but it's not an easy answer to say, because you're looking at all the graphs from different testing. They would all show a slightly different story individually, but you have to look at all the testing together as one. You cannot choose a garment based on tensile strength results only, or just on the PFE results only. So you have to look at all of those results, and you have to kind of weigh it in and decide where would that point be. So when you are trying to decide the lifetime of the garment, you have to be looking at the data a little bit, but also looking at the historical data that we would have. We would know roughly what the lifetime of the garment is. And based on that, we would try to pretty much predict what that lifetime of the garment should be or could be. So we would definitely work with the customer, looking at all this different data to decide what that point is. But I cannot answer you at what point do I class the fabric to fail in reality.
Thank you. Sorry, one more question, if I can. Have you done any study around X-ray sterilisation?
No.
So the question and the answer was, have you done any studies around X-ray sterilisation? The answer today is no.
I think it's quite new on the market. I think it's not much being done on that yet.
Is there any other questions from the floor? I have one that I was just thinking about. I think I put my first cleanroom garment on 32 years ago. So over that time, I've lost touch with garments, fabrics, and a lot of the testing and the analysis that was done. A general question, if you look back over that time, has the change frequency or the life expectancy reduced in garments over that period of time from what we laundered 10, 20 years ago to what you'd expect today? Is it 50, 70, 100 irradiation or sterilisation cycles? And also to cost and availability, what is the motivation today? Is a gown today more expensive relatively? Is the cost of gowns increasing? I'm interested in that generally. I hear a lot of discussion around where do I put my money in terms of our operational costs. Some of what we heard this morning was looking at smarter clean rooms, energy efficiency, and reducing the air change rates, or reducing the ventilation system based on some of the source strengths. So one of the source strengths that comes to a clean room, one of the sources of contamination, comes from the gown or the person inside it. So I wonder if there's anything just more holistically about where the gown fits in that strategy, whether it is a gown costing more as we're going forward? Is that where everybody should be considering spending their money?
I think if you're going to compare it to a disposable option, then especially during the pandemic, we've seen disposables, skyrocket the price, whereas actually garment fabric has remained fairly stable. We've seen other costs obviously increase, irradiation, etc., cardboard, but actually the garments themselves have actually remained fairly stable. So I would say that it's actually that option in comparison to a disposable option where, of course, they have their place in the world, but a reusable option is going to be more environmentally friendly, and of course we're all concerned about that these days. And also you are going to get better value for money. And with us doing this type of study, we want to be able to say, right, well, can we lengthen the life cycle of the garments that you have in use? So a typical clean room contract for garments is usually 3 years, and we factor in roughly around 50 processes within that 3-year period. That's a typical garment contract, but of course each customer is different. So we then have to build that into the contracts to say, can we extend the life? So I think it is very much down to individuals and how they're wearing them, and what they're being put through in a typical day-to-day scenario. But yes, I think we're always looking for improvements, and that was part of our study, wasn't it? I think, to say, are we using the best fabric out there? Are we giving customers the best offering? Should we be considering others that are going to perform better in future?
Thank you. And you're a clean room user yourself, so I know in your ISO 456 facilities, then some of what we've been talking about in energy efficiency, I'm sure will be of interest to you just as much as it is to the customers of Micronclean.
Yes.
So, no, thank you. Any more questions from the floor? If not, we will move on. Thank you very much then for your presentation, you both.